So in y equals, we put in 2.9, the square root of x, and then plus 20.1. And they want us to plug in. I have to always change this. It goes to default. I'm sorry. Okay, second in table. And I plug in 48. And the model gives the height at 48 months, 40.2. So I will write 40.2 inches. Then the problem says the actual median height for boys at 48 months is 40.8 inches, not 40.2. How well does the model describe the actual height? I think it's awesome. Just a tiny error, less than an inch, right? Not even half an inch of an error. So I think the model is quite good. Part C, use the model to find the average rate of change in inches per month between birth and 10 months. We're going to do that in a minute. Use the model to find the average rate of change in inches per month between 50 and 60. Okay. But I want to determine the numbers first. So they say between birth and 10 months. So I'm going to put 0 and 10. And what else is there? 50 and 60, correct? Yes. 50, enter, 60, enter. So I have all the numbers I need. So I highly recommend when you are asked to evaluate a function for different values of x, always put in the function in y equals. Always. Instead of just punching in a number like 5 times different number in the graphing calculator without creating that function. It's always better to do that because you can make an error punching in it several times. Okay, so let's go back. Okay, do I still have time? Yeah, I do. Okay. So this was problem 127 on page 296. Okay, so we are given the function f of x equals 2.9 the square root of x plus 20.1. In part A, we will say the square root of x is the base function. Then we have 2.9 the square root of x, which is vertical stretching. And then 2.9 the square root of x plus 20.1 up 20.1. This was the description of what we see. That's the function that was used, the model that was used to fit the given data. Part B. What is the median height of boys that are 48 months old? So in part B, f of 48, we got 40.192 inches. They say that the actual point was at 40.8. So actual height, 40.8 inches. So it is roughly a little bit more than half an inch. So I will say good. Not best, but very good. Very good model. At 48 months, I don't know if I would say the same thing at 50 months or 20 months or 100 months. I don't know. But at 48 months, I would say it's pretty good. Part C. Use the model to find the average rate of change in inches per month between birth and 10. Average rate of change between 0 and 10. What is the formula for the average rate of change? We looked at it last time. y2 minus y1 over x2 minus x1, or f of x2 minus f of x1 divided by x2 minus x1.
We need to memorize that one, right?
It's the slope. It's the slope.
You're going to give us for the test?
It's the slope. The slope between 2 points. So then we have f of x2, f of 10 minus f of 0 divided by 10 minus 0. f of 10 minus f of 0 over 10 minus 0. F of 10 I calculate to be 29.271. F of 0, very clear, 20.1 divided by 10. Tell me what you get. 29.271 minus 20.1. I got 0.9171. Measurement unit. 0.9171. Measurement unit, please. It's a rate of change. It has to have two measurement units. One coming from the measurement unit for the top over the measurement unit for the bottom. What is measured? What is the measurement unit for the top? What are these?
Height?
Inches.
Okay.
And this?
Years.
Good. So it appears, because it's positive, it appears that between 0 months birth and 10 months old, it appears that boys grow at a rate of roughly about 1 inch per year. Oh, month. Sorry. We're talking about months here, not years. But it's time, but not years. It's measured in month.
Oh, the graph had months, not years?
Yes.
Oh, because it had like 50 months.
Yes.
Okay.
Yes. Good. Part D. Use them.
I'm
Yes.
still a little confused on the C part, like you did it really fast. Like where did the 29.271, like I know the numbers are up there.
Yeah, we plug them in. We plug them into the function. It's f. F of x2. I plugged in 10 in the function. 1 second, Priscilla. I plugged in 10 with the graphing calculator. F of 10. This is x2 and this is x1.
Okay.
I plugged in f of 10 and I got this.
And
F
you
of
put it like that, f of 10 in your calculator?
I created the function. Here's the function in y equals. This was the function. And then with second and table, I determined all these. Because I didn't want to go back 5 times and plug it in.
Okay. I guess I missed
That's
that
fine.
part. Okay.
Yes, Priscilla?
Thank you.
The F of X, is it XT? You go back. Next to the average rate of change.
Between 0 and 10.
No,
F of,
is that like the formula for?
yes, we discussed it last time. The average rate of change, that's the formula from last time. F of x2 minus f of x1 over x2 minus x1 is the slope of the secant line on the graph that we looked at last time.
Can you just look at the top real quick so I can copy the page?
Oh yeah,
I just want to copy the page.
296.
Which part of the, like, in the graphing calculator did you go to input the numbers?
Y equals. Oh, after I put in the function in y equals, then I go to second and table. But you have to be second and table set. Make sure that the independent variable is in ask mode. Otherwise, you will not be able to plug in your own numbers.
Oh, okay.
And then you go to second and table and you plug them in so you get all of them at once.
So independent, I switch to ask.
Only for x. Only for x.
Is X the independent? Oh, correct.
Yes, x is the independent, yes. Part D. Use the model to find the average rate of change between 50 and 60. So the average rate of change between 50 and 60, the same thing, will be f of 60 minus f of 50 divided by 60 minus 50. I have the numbers, I just determined them a minute ago. So f of 60, 42.563 minus 50, 40.606. Everything divided by 10. So let me know what you get. Don't torture me, give me the numbers. I got 0.1957. Correct me if I'm wrong. 1957. I need the measurement unit, please. Average rate of change between 50 and 60. Very good. Inch per month. So now, between 0 and 10, they grow at a rate of almost an inch per month. But between 50 and 60, the rate of change is much slower. Look at my hand, and that's the graph. That's why the rate of change between 50 and 60 is much slower than the rate of change between 0 and 10. And the question is asking us to, how does this compare to your answer in part C? How is the difference shown by the graph? How is the difference shown by the graph? Exactly how I presented it, right? Between 0 and 10, the graph does this. But then between 50 and 60, the graph does this. So how does this compare? Roughly, this is 5 times as much. So if you multiply this by 5 roughly, you'll get that. So 5 times as much between 0 and 10. So on the graph, if you want to illustrate that, here's how we get that on the graph. So here's the graph one more time. So this is between 0 and 10, and this is 50 and 60. So here's the slope. The slope between 0 and 50 is almost 1 inch per month. The slope between 50 and 60 is only 0.2 per month, inch per month. Right? So this is 5 times as much between 50 and 60. Any questions? Any questions for me? Any questions? Any questions? Put these together, please. So this is just a sample of problems that we covered in class. Thank you. Please work diligently on all problems. Go back to your notes, review the problems we did in class. Yes. Only
Here, I can't just open it for the site. Okay, so.
Thank you. So please work on all the all problems between now and Monday. Hopefully, we will not need to spend a tremendous amount of time or the entire class to cover this.
This is studying.
No, they're together.
These are all
The
tests.
same test. Same test. So that's probably, as you know, this is not in my math lab. This is not in my math lab. That's it's separate. Yes.
Will the actual test be the same format?
No, I'm gonna write it.
Okay.
Yes.
So basically,
Oh, yeah.
If you know how to do everything we've done in class, you will get an A in my class forever.
I'm sorry about
And it's all that worked on since day one, right?
I'm sorry?
So this is like basically a review of everything that we've done since day one.
Oh no, I can't put on any test everything we've done. There is no way. Then you will be here the entire day,
Okay.
which is fine by me, but I will not torture you. There is going to be a selection of problems that we
Yeah,
covered
I
in
missed
class.
the previous class. It was a Monday as well.
Okay, I missed that too, yeah.
But she does upload onto the.
Okay, Bailey, can I show you here? So you go to home. Okay, so you just go to home and you click on anything in there. It's in order. They're all in order, as you see, with lecture notes. You should go here, not to the YouTube channel, because you have the lecture notes attached.
Yeah, I think I was doing like the notes instead of the video.
So it says video and then lecture notes.
Yeah.
It says video. So when you click on a video, and then at the top, it takes you to, and you can use your tablet, you can use your phone.
I always have to hit the top. It'll never show up in that box. So don't freak out, it won't ever.
I have 4 more minutes, please, please. Okay, so is there any particular type of problem that you would like to see again before the test? Any problem that you would say, well, I need to see another example because, you know, maybe we haven't done enough or we need more?
I have a quick question.
Yes.
Like your video, it only has 21 questions on it. Should we expect the test to only be about 20 questions?
Yes, I would
Okay.
not be no more than 20. Okay, so any type of problem would you like us to review right now? We still have a few more minutes. I don't want to waste time. Anything you like, any type of problem, maybe graphing a piecewise defined function, maybe another difference quotient, maybe some equations that you would like to go back to. Any type of equation. Anything. Should we go back to lines? Maybe graph a line, maybe find the equation of a line given some information. Anything you'd like to see?
I'm confused by the papers.
Uh,
Just there's 2 of them and they look different. Is this how the test?
As you know, there is no such thing in my math lab, that simplification. So it's part of the test. It's going to be part of the test. But I couldn't print it out for my math lab because it's not in my
Oh,
math
and
lab.
this is from my math lab.
Yes.
Okay, so you just wrote it.
It's
in-
everything
okay.
is together.
Okay.
It's everything is
I just saw the 2 different formats and got confused.
no. You're
Yeah.
gonna have it written, and you have to present all your work. But I just gave you an example
Okay.
to work on between now and Monday. So, is there any type of problem that you would like to go back to? Anything? You can choose a problem from there if something appeals to you, or
Wait, what day is the test? Monday or
a week from today.
Wednesday?
Yes, a week from today. The test is from a week from. Yes, Priscilla.
Can you do that for 10?
Okay, what does it say?
Use the graph to find the following.
Do you want to use mine really quick?
Yes.
It's like a question I was going on.
Yes. Yes, for number 10, so the function domain will be between -3 to 0 with a bracket. The function's range will be between -1 and I believe it's 8 with a parenthesis. The x-intercept will be a -1, 0. The y-intercept will be 0, -1. Ladies, please. Thank you. Please. The function value indicated below, f of -2. So I have to draw a vertical line at -2. And I think I will be reading maybe +3. You have to look carefully.
You said the range was -1, -8.
Yes,
Where'd you get the 8 from?
the highest number from the low to a high on the y-axis. Yes, please, Mana?
So the test is not Monday, it's Wednesday.
Yes, a week from today.
The class that we're talking about last class, is it gonna happen now? Or?
Yes,